Hey, it's Bill Tromley from Tromley Tool in East Troy, Wisconsin. This is video number 2 on the video series for building the gas tank for the 1931 Curtiss Wright Travel Air 12W. Today, it's Friday afternoon. We finished up a bunch of stuff, and I thought I would show you some of the pieces that were built and maybe some of the tips and tricks that could be used to help with the building process. It's basic stuff, straightforward sheet metal brake work, putting in holes, bending, stuff like that. But, you know, some of these tips might help out. So if you look at here, and I have a list to help try to keep track of it. This is the form block that I had made, and there's the rib. This is 50-52 aluminum by 50 thousandths thick. Nice, clean, no tool marks in it. The way we like stuff, nice and straight. So for cutting out the sheet metal blank, you know, I wanted a 3/4 inch flange on this block. So how do I scribe that line on there? So I set this on my blank piece of aluminum, and I have this very simple tool here. You can see I got several different sizes in this Ziploc bag. And all this is a piece of Delrin turned to the diameter that I would want. So the radius would be half of that. So I wanted a 3/4 inch flange. So this is 1.5 inch diameter, 3/4 inch radius. And then through the center, I drill a hole 3/32. And fits a piece of 3/32 of an inch tungsten from the TIG welder. So this is an old piece of tungsten. It's getting pretty short, and I grind a point on it like that. Now I got a scriber. So I set this, and it bumps up against the wood form block, and this rides across there. And no matter how this is orientated, because it's touching on the tangent point, and it scribes the line. So you need an exercise different offset, then just make up a different diameter piece and just reuse the tungsten over and over. Once you scribe the line, now I got a line that's parallel to this. This here is actually made of 2 basic radiuses. This is a radius sweep, number 9 sweep from here approximately, going this way, and then it blends into a number 29 sweep here. So instead of doing a bunch of math and all this calculating, I just need it to be a parallel line. It's a pretty simple, easy thing to do. You don't have to have fancy equipment to make something like that. And it works very well. So give that some thought. Next item here. So when you're shearing something in the foot shear, on my foot shear, it's a 50-inch shear that I bought many years ago. Bought this from an old friend of mine down in Kenosha Airport. And one thing you'll notice is the hold down's gone. The hold down bar. They have a big coil spring in here and a big coil spring in there. I never liked those anyways. You can't see where you're cutting. There's a little gap and everything else. That's kind of a pain in the neck. The other problem with stomp shears or foot shears is it can be a challenge to cut in a straight line, especially the longer the cut. And what's happening is as that blade is advancing through the material, it can actually steer the material. And that's what that hold down clamp was for, was to try to put enough pressure on there to keep that from happening. What you can do though, tin snip, and you mark it. I use a scriber, a carbide tip scribers. They're inexpensive. I buy like 4 at a crack. Carbide's awesome until you hit it. Like try using it as like a center punch, and you'll instantaneously smoke the carbide. But you'll get a nice tight, or a nice clean looking line. But take the tin snip, and you take this line and you put in a sheared notch like that, and right hand and a left hand tin snip. And we can discuss, we can do a video in the future if people are interested, is to wire the right hand and left hand tin snips. It's not if you are right-handed or left-handed. There's a reason why that they're actually offset that way. But what you do is you put in a notch like that. See that? On both ends. What that does is it hooks the blade, the shear blade. So now it comes in and you pull it tight against the blade. Another thing is if you had the hold down clamp on there, it's hard to see. So if you put that initial notch in there and slid through until it snapped down, with the hold down bar, then you know that you're lined up with your marks. If you don't have the hold down like what I have, it doesn't allow the sheet to turn. So it guarantees that every time you shear, the sheared line is straight and it's where you want it. So and it works good every single time. The other thing I do is the cutoffs, I always label it. You guys go, well, you know, I'll remember. You won't remember. For us, we're labeling material all the time. You know, all of the bar stock that we got in the shop for machining and everything is always labeled. Some of the stuff's getting to be pretty damn expensive. I can't have a customer call out on a piece of 303 stainless steel, find this, you know, in a chunk that's 6-inch diameter in the stock rack with no label on it. So label your materials. I always put on there, what is it in thickness. It seems obvious to some until you go in their shops and you realize a lot of people don't do it. So, but that sheared line, you know, now these are exactly parallel. I don't have any wandering issue with it. So that works really good, is tin snips in the foot shear. Over here, when it comes to putting in holes like this, so in this rib here is 3/4 inch holes at the bottom, and that's so that fuel could drain from between one rib bay to the next to the next. So these holes here, you could punch them if you have a rotary punch like what I have, and punching is great. But what about if you're going to drill them in? Some of the best hole saws that I found on the market, I would say they're Hogan, H-O-U-G-E-N, rotocuts, and they're high-speed steel cutters, and these cut size, and very accurate, very clean-looking holes. If you think of a hole saw, like the ones you get from Home Depot where they're sheet metal, if it's a 2-inch hole saw, cut a hole. I don't know in what universe it actually ever measures 2-inch at. I've never had that work. Where this company sells high-speed steel cutters that are pretty big. I think I got one up 3-inch in diameter or something like that. And they're cut and machined or made just like how we'd have like an end mill cutter in our shop or something like that. So super high quality. You can see here I got one on my electric drill. And it comes with this spring-loaded pointer on it. You know, and the idea would be is you'd center punch it, and then you would use this to locate off of that. Well, I've had that where I tried that. I center punch it, and as I'm cutting, all of a sudden, I'm not perfectly straight. The cutter catches and walks across the part, and I get these deep, huge scallops in the piece. Well, that pin is 1/8 inch diameter. So I have in my pneumatic drill, number 30 drill bit that we use for aircraft rivets. I just pre-drill it. Center drill it, or center punch it, and then now, and then especially if you do it like here on the wood, is that pin is engaged not only through the part but also into the wood below. One more time. out of battery. But now a super accurate clean hole, exactly where you want it. You don't have it squirting around on the tabletop, and didn't put any marking on it. For us, we use deburring tools here in the shop every day. That's standard handheld one. That works well. We always deburr everything and radius it off. Another thing, you can find them, but I don't have a good name for them. It's a 3M product. And it's a hard paper wheel like this, used on a 1/4-inch die grinder. You guess you'd have to research it. You can find them on eBay, especially in aerospace stuff, and it's this hard paper. And you go around with it with that, and it'll make that edge a super soft, shiny edge. And it's a very quick, efficient way of deburring an edge. You know, you want these edges, in aluminum especially, to be smooth like that. If there's burrs on it or marks in the edge, that's where cracking can develop. In the airplane world, it's very critical for us to do that. So it's a very nice product for that. For accurate marking or center punching, a long time ago, I mean it's probably 15 years ago, I switched over to these spring-loaded center punches. You find them in the hardware store, usually in the, they're used where I seen them, where I got this one, was where they would sell the finishing nails. And one side of it actually was not a center punch, it actually had a cup on it, and that cup would fit the head of the nail. And it's for doing the final set on a nail and a piece of wood trim. The benefit with the spring-loaded center punches is it never fails. For a while I was buying the automatic center punches, and eventually it's like the guts give up on the inside, and then they're junk and you throw them away. And it didn't seem like a matter of which quality unit I would buy. It would sometimes last for weeks or months. You know, if you could get a year out of it, it seemed like you were doing pretty good. So one side I have is a traditional center punch. The other side, where that half round was cup, I actually took and I reprofiled it, and I made it a much more of a dollar center punch. So it's very much rounded on the end. And I used that, like on this panel here. This is the wheel brake cover for the Fairchild 24, and there's a dimple that I put in. And what that was is, during the metal shaping process, sometimes you need to have a witness mark that doesn't get rubbed off. You know, it's going through the power hammer, or thumbnail dies, or whatever the shaping process is. And you need to have a dimple that stays versus an ink mark or something like that, where the oil softens it up and it goes away. Yet you don't want to have a stress riser, and you don't want to have this ugly looking center punch mark in there. So you want it to be just enough of a mark that you can find it, but would easily get covered by paint. And it's something that if you handed this cover to most people now, if they went looking for it, they'd have to go looking for it to find the center punch mark. So that's a nice benefit to doing on both sides. So have a sharp side and then a dollar side, for putting in that mark that you need it, but you'd prefer if you really didn't have a hard hitting center punch in there. And this thing won't fail. This will just run and run and run and run. It's just basically a kinetic hammer, I suppose you could say. And also too, I find it's easier to use. The automatic center punch, you'd have everything lined up, and when you're coming down, as soon as it would snap, sometimes you'd see that you'd be off your mark. So here you just set it where you want, lift up on it, let go, and now you got a nice center punch. Inexpensive, Home Depot kind of a purchase. So it's something to think about. So what else we got? Lubrication. If you look at these, hole punches that were put in there. So these are the flanged holes, flanged lightning holes. All the aircraft stuff's full of it. Guys building bomber seats like that look. Interior panels, people like that look. Why is that done originally? That was a question that came up recently. Is its strength. If this center field out here, if it just had a punched hole in it, it has no rigidity to it. So by putting that around the edge, it mechanically locks the edge and it makes the center of whatever the skin area is, stronger. And that's why that's put in. So where does the lubrication come in? These are the hole punch dies that I use. These here, we've never found a manufacturer for them. These are not actually mine. A very good friend of mine, Sam, got these from the airlines, and he's here on the airport. And I'm trying to get in the will to eventually get these from Sam someday when he's done with them. Because these are the best hole punchers I've ever used. And we think they might have even been made by, it was a local airline here, Midwest Express Airlines, and they might have even been made by the airlines themselves. Super high quality, uses a 3/4 inch dowel pin locator. But what's important is lubrication when punching. So I use, it's called Bow Shield T9. Anything would be fine. The reason why I like this stuff is it's rust and corrosion protection, waterproof lubricant. It's a Boeing product. And what's great about this stuff is I spray it on all my tools, my bench heads, dollies, tools here in the shop. We don't have any rust problems. Sometimes even in the spring when we got the hangar door open and you get that light spring rain mist come in, you know, we're worried about all the exposed steel in here rusting. And this stuff does a really good job. Well, lubricate the die, lubricate the punch. I know you guys are using these or Greenlee chassis punches. You see so many guys, they punch dry, right? Even if you had a Rotex punch like the one here in the back, any of it. Lubricate your tin snips. For tin snips, I'll use Bow Lube itself. This is a paste form. And like that. Lubricate your cutters. Now, you say that and people go, I'm punching. You know, why would you need a lubricant? Well, if you're drilling a hole, you know, you put cutting oil on it. Well, if you were to look at the drill process of the actual cut, the actual cutting surface at the material, it's a shear that is going across on the drill bit. So it's shearing that material off as it's going down through the hole. It's a shearing process. It's no different than this. It's just configured differently. And lubricant will lower the amount of pressure it takes to push through the material. So you'll find it on your hydraulic press and everything. It actually takes less poundage to be able to punch the same kind of a hole. It also makes the dies last longer because you're lubricating it. Just like it makes a drill bit last longer when you're using cutting oil. So don't be afraid to use lubricant. When it comes to machining, we never use WD-40 or anything like that. We use a cutting oil. Would a cutting oil on this work better? Sure. You know, what's different a little bit is yeah, remember there's a lot more friction in drilling. And I suppose you can make the same argument here. But lubricant nonetheless, cutting oil nonetheless, Bow Lube, any of this kind of stuff makes it last longer. Tin snips, you'll find that the tin snips actually cut a lot easier and don't have that curl seem to be sticky when you put just a coat of Bow Lube on it. And you don't have to have it dripping. It's another thing. People go, well, if you're going to put lubricant on it, you got to have a lot. No, just enough. Just coat it and it'll be fine. And then also what's nice with these hole punches is you don't go back 6 months later and I go over by Sam to pull out of his cabinet and they're rusty. Why? Covered in oil. It's a good thing. So lubricate your tools, punches, and that kind of stuff. even your tin snips. So that's something to think about. Let's see here. And then the other thing too is magnetic sheet metal brake. So over here, this is my Bailey Industrial sheet metal brake. This is a 4-foot unit. This unit, I use it all the time. It's a great machine. It comes with all these different attachments. And as far as a pan brake or a box brake, you just can't beat it, in my opinion. There is a company called MagnaBend. A friend of mine has one. And he goes, you know, he doesn't really care for it. And it's a 110 volt unit. This is a 220 volt unit. So I think the magnet on this thing clamps a lot harder. But another thing that you can do to increase your clamp pressure, I'm going to grab this sample here, is this is 50 thousandths material. Well, you'll see here in the back, this is 47 thousandths. This is a piece of steel that's galvanized. I bought this out of McMaster Car. And what I did was McMaster sells steel in varying ranges of thicknesses. And I got 25, 37, 42, something like that. And I got these varying thicknesses, and it goes on the back side of the magnetic hold down clamp. And here's why. What you want is when the clamp goes down, it stays parallel. If you don't, and I'm only bending a 3/4 inch flange, so what happens is this top plate's not supported. So then what happens if you don't have anything behind it is it rocks like this, which means then it's only touching on one point. And then what happens is you got all this mechanical pressure going up and you lift the top clamp. And then guys go, well, these magnetic brakes are junk. Well, by putting in the shim on the back side, that top clamp stays level. I went with galvanized steel is because it's magnetic. I'm trying to give it every chance I can get to stick. Another thing with a magnetic brake is you can build different kind of hold down clamps like this. So this is I think a 1/4 inch rod on a 1/4 inch rod on this side and a 3/16 rod on that side that I tack welded to this piece of steel. And I got here's one with the bigger pieces of tubing like that. That's another beautiful thing with magnetic sheet metal brakes is you can build your own top down hold down clamps. Well, here, this is pretty thin. It's a 1/4 inch piece of bar stock and probably 2 inches wide. And it had to stay this way for the particular project that I was bending and needed the room. But if I'm using it other times, and it was thin material, all of a sudden you'll find this pops. And you gotta remember, it's magnetic lines of inductance that are going through this machine. So if this is very thin, you're not giving it a lot of material for the magnet to stick through. So for us here in the shop, we got blocks of steel. Add a block of steel on there. Now you're giving something more for the magnet to bite in essence, to put it in easier terms. If you look at their hold down clamps, it always has a sharp edge on there. Not even really radius, it's a little bit of a flat. What happens if you want a bigger radius? You could offset this by going back, that's one way of doing it. And it works. Another thing you can do, this is a piece of aluminum strip, and just bend a piece of aluminum strip. Now by adding that on there, you're increasing the thickness, which then makes the bend radius become larger. Comes pretty easy. Another thing too that I do is I take a piece of masking tape, put it on this piece of shoe here. That's the lifting shoe that comes up. And that eliminates the scratching you see on the back side of the panel. You see a lot of nice looking bent sheet metal pieces and it's got all these scratches in it. Piece of masking tape, just wipe it down, put a piece of tape on it. And you can do bending like this and it's tool mark free. So, and it's a very efficient as well. If I had a line on there, one thing I always try to do is once I get where I want, I rock this down to make sure that it's lined up with the line. Hit the pedal and bend it. So now like that, nice bend radius and everything, because the aluminum piece is allowing that to happen. You want that more, put 2 of them on. Each time you're doing that, it has to further distance for it to bend around. So, and that's another idea to help with the metal shaping, or the projects like what we've been dealing with here. So, and that should be pretty well, give you a good idea of some of the parts we made and some of the things that we used to help build the pieces that are here this week. So next week we'll have more pieces as far as the actual tank skins to build, and then there'll be some Polmac stuff for that. The tanks are welded together, and then we'll be doing some weld work. So that's what I got. Thanks.